Alright, so counting principle. When dealing with the occurrence of more than one independent event or activity, it's important to be able to quickly determine how many possible outcomes exist. So first of all, we're going to go through and we're going to do it where it's not the quick way. And then we're going to show you what the quick way is, and it's going to be way easier, and we're going to be done like that. Okay? Because we want to actually show you how to do a diagram, and how to do a tree diagram, things like that. Alright? What? No. Alright, so if ice cream sundaes come in 5 flavors, strawberry, chocolate, vanilla, mint, lemon, with 4 possible toppings, how many different sundaes can be made with 1 flavor of ice cream and 1 topping? Make a list of all possible sundaes. Well, strawberry, cookie crumbs, strawberry, fudge, right? Make a list, it says so. Strawberry sprinkles,
Way too long.
strawberry nuts, chocolate with cookie crumbs, chocolate with hot fudge, chocolate with sprinkles, chocolate with nuts, vanilla, cookie crumbs, vanilla hot fudge, vanilla sprinkles, vanilla nuts, mint, cookie crumbs, mint hot fudge, mint sprinkles, mint with nuts, lemon, cookie crumbs, lemon hot fudge, lemon sprinkles, lemon with nuts. Right? So just writing out all the different combinations. How many different combinations did I come up with? 20, right? We did 1 flavor of ice cream with 1 topping. We should have got 20 different combinations, right? 20 where there's 1 ice cream and 1 topping. But do we want to do that all the time?
No.
Yes, you do. We can do all the problems like that.
No. No.
How do you do it quicker then? Well, I heard someone say it. We just multiply the number of choices for ice cream by the number of toppings, and we get all the different combinations we could have. Right? If we took the 5 flavors by the 4 toppings, we would get 20 different combinations, right? Alright, an additional question. It's not on your paper. Let's think about it, because it might get a question asked like this at some point. If we're allergic to nuts and we just like lemon, and you order a sundae, but the lady behind the counter forgot what you ordered, what are the probability that you will not want to eat the sundae? Right? So you order your sundae, right? Lady behind the counter didn't write it down, forgot what you wanted. What's the probability that it will contain either nuts or lemon? That you won't want to eat it? How can we find that? Well, one way could be, just go up here, circle how many have nuts, circle how many have lemon, and count it up, put it over the total number, right? Which would be how many? 8 out of 20. Which is the same as 2/5, right? What's the other way you could have done it? By using probability. What's the other way we could have looked at it, like we did yesterday? What's the probability that one of these has nuts? How many of them have nuts? 1/4, or 5 out of 20, right? How many of them have lemon? 4 out of 20, but be careful. Didn't we count one already? It would have been double counted, so it would be 3 out of 20. And because it's or, we would add them. Right? So same thing, 5 plus 3 would give us 8 out of 20. We'd reduce it 2 out of 5. Now, like I said, we're not going to list out every single one in every single of these problems. We're going to start using that counting principle we talked about. And I want to kind of click through it, so I don't know if you wrote it down or not. Where we can just multiply the number of choices for ice cream by the number of topping choices. Right? Multiply it out. Now, the next one we are going to do a tree diagram. Right? We're talking about cars. We're buying a new car. There are 2 different body types, sedan or hatchback. 3 different colors, 2 different models. We don't know how many different choices of car we have. We want to make a tree diagram. How do I make a tree diagram? Leah, what do you think?
Put the two different bodies up top and then.
Okay, well, hold on, I'm not that fast, man.
Oh, okay.
Sedan, hatchback, put them on top. Two different body types on top. All right, what next?
The three different models for each, I guess.
The three different models.
Or the colors.
Three different colors, right? Split up into colors. We have black, we have red, and we have silver. Black, red, silver. And then what?
What was the last thing? Oh, the two different models.
The two different models, right? Split each one color into two different models. You have a different model for each. So it was the GL or the SL. GL or SL. GL, SL. All right, now back to the original question. How many different choices of cars do you have? I drew my tree diagram. How does that help me? How do I figure out how many different choices I have?
Multiple. You count?
Count what?
Count the end results.
Count the end results, right? Each one of these is a different path I could take to making a car. So if I count my end results down here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I know there are 12 different choices of cars that I have. Okay. Another additional question, not on your paper, we're going to kind of talk about it. If you love sedans that are the SL model, so you love sedans that are SL model, what's the probability of randomly picking a car and it being a sedan and an SL model? In other words, what's the probability of a sedan and an SL? Well, what's the probability to pick a sedan? 1/2, right? It's either a sedan or a hatchback. And means I'm multiplying. What's the probability that's an SL? Why is it 1/2?
Because it could either be SL or GL color.
Could be either SL or GL, and we don't care what the color, right? So we do 1/2 times 1/2 would give us a probability of 1/4. Or you could have went up here, could have been like, well, sedans, there's 1, 2, 3 out of the total 12, which is the same as 1/4. Right? So either way you want to do it, there's multiple ways to do it. If you draw a diagram, pretty easy. Otherwise, just do using our probability that we learned yesterday. How could we do it with multiplication? What would we have done to figure out our number of car choices if we used multiplication? Multiply what, Colton? You said multiply numbers. Just any of them? Can I pick any numbers? Multiply them?
3 and 2.
3 and 2?
2, 3, and
2, 3, and 2. Okay, so 2, 3, and 2, right? Just keep multiplying your choices. 2 body types times 3 colors times 2 models would get us 12 choices still, right? All right, that's the last diagram we're going to do today, I promise. Okay? We have like 5 more examples and we're done for the day.
What about how about we do 3?
How about we do 5? Because they're going to go really quickly.
Alright.
All right? First one. You have to draw 2 cards from a standard deck of 52 cards without replacing them. How many different choices do you have? Well, let's think about it. First choice times my second choice, right? First, second. How many cards do I have to pick from the first time?
52.
52. So my first choice, I could get 52 different cards. What about my second choice?
51.
51, because I took one out and I didn't replace it. So now I do 52 times, I have 51 choices for the second time. So if I multiply those, that should tell me how many different choices or how many different combinations I can make by picking 2 separate cards. Well, how many different choices do we have? 2,652. That's it. That was pretty easy, right? Does that make sense? Right? That first choice we have all 52 to pick from. The second we have only 51 because we already took one out. What about example 4? You roll a die 4 times. How many possible outcomes are there? Well, if I'm rolling it 4 times, so first roll, second roll, third roll, fourth roll, I know I'm going to multiply these. How many different outcomes do I have the first time I roll it? 6. What about the second time I roll it? 6. Why is it not 5?
Because it didn't say
Previous one.
I need to get it.
The previous one doesn't affect it, right? It doesn't say we can't repeat a number. Doesn't give us any stipulations like that. So the second time I could have 6 outcomes. Third time I could have 6 outcomes. Fourth time I could have 6 outcomes. So 6 times 6 times 6 times 6, or 6 to the 4th power. 1,296 different outcomes. Any questions on that? Pretty simple. Example 5, Baskin-Robbins offers 31 flavors of ice cream. You order a double scoop. And how many different ways can the clerk put the ice cream in the cone if you want 2 different flavors? Okay, well, first and the second scoop. How many choices do you have to pick from the first time you're picking? 31. Okay, for my second scoop, how many choices am I going to have to pick from? 30, right? We want 2 different flavors, right? So once we pick one flavor, we got to take it out. We don't want that same flavor to pick again. So we're doing 31 times 30. Now if it said you could have 2 of the same flavors, we would still have 31 for our second scoop. Well, what's 31 times 30? 930 different combos. 930 combos. 930 combinations. Alright? Any questions so far for those 3 problems? Dos más. Okay? Our state issues license plates consisting of letters and numbers. There are 26 letters. Letters may be repeated. There are 10 digits, and digits may be repeated. How many license plates can be issued with 2 letters followed by 3 numbers? Someone walk me through it. What do I got to do?
26 times 26.
Okay, why are you doing 26 times 26?
So there's 26 letters and they can be repeated.
26 numbers and they can be repeated?
I said letters.
Did I say numbers?
Yeah.
Okay, 26 letters and they can be repeated. And remember, there's only 2 letters that are being used. Okay, then what, Patrick?
10 times 10 times 10.
10 times 10 times 10. Why are you doing that?
Because there's 10 letters and they can't repeat it, and there's 3 in the license
10 numbers, 10 digits,
plate.
right? So there's 10 digits that can be repeated, and we're doing it 3 times, right? It's followed by 3 numbers. So 26 times 26 times 10 times 10 times 10. How many different license plates could we make?
Tons.
Tons, lots of them, right? $676,000 different license plates. Right, it'd be really cool if you labeled them. I'm not, I'm lazy. But don't be lazy like me. Alright? So it's 676,000 license plates. Last one, example 7. Your state issues license plates consisting of letters and numbers. There are 26 letters and the letters may not be repeated. There are 10 digits and the digits may not be repeated. How many possible license plates can be issued with 2 letters followed by 3 numbers? Alright, someone besides Patrick walk me through it.
26 times 25.
Okay, why did you do 26 times 25?
Because, well, 26 is how many letters, and then 25 because the same letter can't repeat itself.
Perfect, so 26 to pick from the first time. I can't repeat it, so it's got to be 25 to pick from the second time. Then what, Q?
10 times 9 times 8.
Why 10 times 9 times 8?
Because the numbers can't repeat themselves.
Numbers can't repeat themselves, right? We have 10 numbers to choose from the first time, then 9, then 8. Finally, how many different license plates can we make that way?
Tons. 468.
What?
468,000.
468,000 different license plates. Alright, any questions? That's all we got today. Look at that.